What is up, you beautiful people? I'm working on something really freaking cool and I wanted to share this with you guys. It is in super early stages, but I got a computer hooked up to my 2022 Indian Chief Dark Horse. I'm pulling messages from the bike. Let me show you what I've been working on. 2022 Indian Chief Dark Horse. What I have here, this is the diagnostic port on the bike. This is a Raspberry Pi, Adafruit, Arduino flavor, pretty much. It has a CANBUS chip on it. And what I'm doing, these little wires under here, right there, the yellow, let's see, where is it? The yellow and green wire. That is access to something called the CANBUS on this motorcycle. And what the CANBUS does, put that back, it allows each sensor to see what data the other sensors have on the bike without having to run a wire individually between those sensors. So let's say, for instance, the screen. How does the screen know how fast the bike is going? How does it know what RPMs the engine is at via the crank position sensor? How does it know that you press this button? Well, there's also yellow and green wires in this, the yellow and green wires in that, yellow and green wires running to this, and all throughout the bike as a separate network. So when those sensors give out their information, they send it to the ECM, and then the ECM sends that information across the CAN bus separately to all of these individual signals in a different way so they know what's going on. So my ultimate goal is to get this screen to work with a Scout, a pre-2025 Scout. Right now, you can bolt that ride command screen up directly to a Scout. It uses the same connector, and the CAN high and the CAN low pinouts on the electrical harness are the exact same. The problem is the screen just will not work. And the reason the screen will not work is because this screen is receiving, at least I think, is receiving different CAN bus messages that require it to work. So think about it like this. If the speed comes across the Indian Chief as a 5, let's just say an arbitrary number, it comes across the data stream as a 5, and that's what the screen knows is a 5, and it displays it on the screen. On the Scout, that 5 may be a 2. So it's sending data across as a 2, and then the screen's like, I don't know what this is. So the goal is to figure out the CAN bus messages for a Scout and figure out the CAN bus messages for a Chief, and use this device to read it, and then also use this device to transmit. Because what we can do, being that we have access to the CAN bus, we can inject messages across the CAN bus to make the bike, or at least the screen, think that it's on an Indian Chief when in fact it's on an Indian Scout. But let me show you this. Let's go ahead and plug it in. I'm gonna plug in. I'm gonna power the bike on. Once I press this button, you're gonna see a lot of data come across this. Watch this. So this is all the data. It is in hexadecimal. Got my code in. Watch when I hit OK. You're gonna see, I guess, the passcode for my bike is gonna get injected across the CAN bus. You're gonna see it release. Watch. See that? It just opened the bike up. So more information came through. So we're gonna hit OK. But my goal right now, I have to reverse engineer what all of the sensors are on the bike, because all you get is hexadecimal. We don't know what any of this is, right? And unfortunately, I'm not getting the frequency of what each sensor is, because the higher the frequency, the faster that sensor is going to be putting out information. So what sensors on the bike are most important? You know, it's going to be your brakes, it's going to be your speed, it's going to be your crank position sensor. Sensors that don't need as much updating, so they're going to have a lower hertz rating. Your turn signals, your horn, your brights, they don't have to be updated, because these signals are coming in so many milliseconds, right? So right now, I think, let's go back. I am getting 200, I have 248,000 messages that have been captured on this bike, and it's doing it 200 and something every second. I've been at this for about a week. I had to, go back and find the code that was needed to make this work and tweak it a little bit. And then I found this pinout on eBay. Well, not pinout. I found this connector that plugs straight into the diagnostic port. This is actually a GM connector that plugs straight in. And because what I was doing before, I was just literally taking some wires and just plugging straight into the diagnostic port. And I also made a cut into my harness over here that I've actually hidden now that I got my pin out. So let me show you this. This is how easy it is with the software. So brake switch, right? It's either on or off, okay? So what we have to do, and I could make this easier by isolating stuff. So these are various sensors that are just going to be going on and off. It's going to be chattering. So a brake switch is going to be one or two things. You either press it or you don't. So we should see a flash right there. See it? CC. That's on the switch, off the switch. So that lets me know that whichever hex ID that is, that's the brake pressure switch. So if I press the rear, same thing. Let's see, right there. On, DC, off. So that lets me know in the CANBUS, Ambient is using the same CAN ID and bit location for the top and the bottom, or the front and the rear brake pressure switch. What about the clutch switch? Same thing. It's either you're on it or you're off, right? I'm holding it right there, off of it. On it, off of it. So that lets me know that's the clutch switch. All right, let's do something more engine related. What about the gear? Neutral. First, okay, do the same thing. Let's see if we can find it. Multiple things changed. Oh wait, I was squeezing in the clutch too, sorry. Because it makes it easier to change. It's probably gonna be right there, that 4E. That's probably neutral, and 31 is first. Again, neutral, first. So that's not to say other things aren't changing, right? Because when you put the bike in neutral, what also happens? It allows you to actually put the bike in run position to prime the fuel pump, right? But if I press that button, we should see it show up on here as well. Right there. That's it. That's the starter button right there. On, I'm pressing it. That's it. But if we're in neutral, let's see what happens when I hit the same button. It's gonna light up because the engine's gonna be trying to start. So we're gonna get crank sensors and all kind of stuff. See that? A lot of stuff just came across. So that's what I'm having to do right now, is to kind of reverse some of this stuff, because that crank sensor, that's important because that's gonna give us the RPM. And then at some point I gotta figure out what are the front and the rear wheel speed sensors are. But let's see, what about the brights, right? Because that's what we need for the ride command too, right? Let's see, headlights. Let's see, where is it? I'm flicking it multiple times. That's gonna be it right there. That's the headlight. What about high beam? Okay, same thing. Let's see, high beam is 4C. Low beam is 1C. If I flick it, it's 5C. So these are two separate buttons. This one is 5C and this one is 4C, but resting is 1C. Okay, what we got here is a wheel for a 2022 Indian Chief Dark Horse on a balancer, and we have a wheel speed sensor connected to the harness. So what I'm trying to figure out is what CANBUS ID the rear wheel speed sensor is. It's easier for me to just spin this and, you know, check the screen and check the software to see what the information is coming across versus trying to spin this by hand, because it doesn't really spin well once it's fully connected. I'm going to spin the wheel, and all of these little signals that are like going across the screen, once I see that the wheel is spinning, I can actually isolate everything to figure out what exactly is the speed sensor. So I'm going to spin this. Speed is actually calculating. So you can see right there, I'm pretty sure that is our speed. So let's see what happens when I stop the wheel. I'm stopping the wheel. It's going down. Red means it's decreasing. Green means it's going up. So let's spin it again. Green means increasing, red means decreasing. Being that it's constant, it's at 4 miles per hour right now. Let's see, let's slow it down all the way down. Red, red, red. I'm pretty sure that's going to be our speed. Yeah, let me show you guys. I think this is actually the speed. I was looking at the wrong one. Let me show you this. So let's see, let's spin this again. Make sure that sensor's connected. Okay, we got speed. What I thought was the speed was this. What I actually think it is now is this. Because multiple bits can be triggered when something's happening, but I'm pretty sure I think these are in conjunction. So I got to figure out what's going on with these. But now you can see why it's better to have this thing kind of here on the side versus trying to do this manually and try to check the screen to figure out what exactly it is. But I'm pretty sure it's this combination right here. All right, so when you're doing this stuff, what you think is something is sometimes not something. So I think I do have the speed, but so the way that this sensor works, the toner bearing has these little notches on it, and the sensor has 2 points on it. And as those notches pass those 2 points, that is how it determines how fast something is passing by the sensor, and it detects the speed in a nutshell. So as I'm going to be doing this, and we're going to see where it triggers on this map. So what we're looking at are the various bits of information, okay? And this is what's going to tell us what's what. So see how that changes? So I'm slightly rotating the wheel, and every time I move it, that bearing is passing that sensor at a certain point and it's causing it to pick it up. Same here. You see that it's going crazy. But watch when I spin the wheel. The speed currently says 0, okay? So let's find that point again. Right there. So we're going to look to that bit right there. And I'm going to spin this wheel. Let's see. We'll spin it. Make sure that's contacting it. Okay. So we got 4 miles an hour. That's what it currently says. Okay. So if I come back down here to where those bits are firing up, what do we got? Right there. 5 miles an hour. So when I slow, now it says 4. So it's pretty much on the edge of 4 and 5. Okay. Right. That's what it still says. So when I slow this down, that should go to 0. Right. And you saw it decrease. So now it says 1. The wheel's still spinning, barely. The screen says 1. That's our speed right there. We found it. So now I know exactly where I found that, so I can log that and write it down. I know it can be super confusing. I'm super confused, but that's how we found that information. And now I got to do the same thing for the front, spin the wheel. But unfortunately, it uses a different sensor, so I can't just plug this one into the front harness. So I got to jack the bike up, spin the wheel, and see if I can find it for the front. And once I do that, now I have the information for the front and the rear wheel speed sensor. All right, I got 4 different bits that are lighting up. Spin it up again. There's got to be those right there. All right, I think I got it. I just got to go in and log it. And there's one less sensor that I got to find. All right, so let's do something really cool outside of what we've already done. So the bike says it's currently 92 degrees outside. So I want to know what the ambient temperature sensor is on the bike. So I've got a heat gun, the ambient temperature sensor under here. It's right there. So I'm going to blow this heat gun in here, and we should see this thing flash up somewhere. Actually, I think that's it right there. Let's see. Shouldn't take much. I'm gonna put this thing on low, sprinkle it in there, just like that. Heat it up, and look at that. Right there. That's gotta be it. Check the bike right quick. It says 104 degrees outside. So that has to be that sensor. Oh, it's actually going down. So that's what's translating what we're seeing on the screen. There's a lot of trial and error that's involved with this, but you can see why me doing this with the bike off and not riding is easier for me to do it, because once the bike is started and I'm riding, it's going to be so much more data from all the engine sensors that are running and you're trying to figure out what's what. So the more you can rule out before you start the engine, the better. And I think we got a good amount of sensors, but I'm gonna see if I can find a few more. But again, work in progress. I'm gonna keep chipping away at it, and hopefully we can get this thing working on Scout. Okay, with a little bit more work, I think I found the CAN ID in the software that relates to battery voltage. What I'm gonna do, I'm gonna start the bike, because once the bike is generating power, it's gonna convert that mechanical energy into electrical energy. I haven't found the rectifier yet. I'm not even gonna worry about that, but I wanted this because it's on the screen, but we should see this jump up to around 13 volts. And also I think I have found the neutral switch. I do have the gear indicator CAN ID, but the bike also changes another bit when the bike is in neutral, which I'm pretty sure allows something to do with priming the fuel pump and actually starting it in neutral and all of that. So there's a bit for that. I think I found it. So let's go ahead and start the bike. And once we do that, we should be able to find the RPM via the crank sensor. And maybe I can find whatever this is once we open up the throttle, and we should see that change too. The bike is currently off, but you can see still getting data to the laptop. That's because I logged that session. And so I'm able to go back and just replay everything that I did. And that's going to allow me to, figure out what other things are. So I'm pretty sure I found the throttle position sensor, which is right there. And I'm pretty sure this, along with this, involves the RPM. And I believe one of these involves the temperature of the engine, maybe a cylinder head temperature or intake manifold. I'll figure that out, but the good news is I don't have to go back and start the bike. I can just replay that log and figure it out from there. Like I said, folks, this is super entry level beginning phases to try to get this stuff to work. There's a lot involved with trying to not only reverse engineer a CANBUS, but try to get components to work between models that it wasn't necessarily designed for. This stuff, there is no documentation on this stuff at all. Indian is not gonna tell us what this stuff is. But my goal is to try and get the rod command to work on a previous generation Scout. Now you might be thinking, what about cruise control and navigation and fuel level? Well, the navigation also uses separate components that I think we may be able to get that to work, because that really isn't involving the ECM as much, but also tire pressure. So you can add the tire pressure in the rod command on Chief. Well, that's not going to work on Scout. One, the wheels, they don't have TPMS slots. And also the tire pressure is actually stored in something called the vehicle control module on the Chief. So it sends that information to the screen. And so the Scout doesn't have a VCM. And I think the ABS, for instance, is also on an entirely separate CANBUS. But for cruise control, you need multiple things to work. You need that brake pressure switch, the front and the rear. You need the clutch switch. You need the wheel speed sensors, front and rear. You need the ABS module. You need gear position. You need speed. You need RPM. You need all of that stuff, because you need to be able to cancel it, and you need to be knowing how fast. Also, you need the throttle position sensor to know where to lock the throttle at electronically. You also need to know, like, okay, I need to know when to turn it on. If it's less than 25 miles per hour, it won't activate. You need to be able to cancel it by pressing the clutch or pulling the clutch lever in, or pressing the brakes, or, pressing the actual button that activates and deactivates cruise control. You need to be able to set it somehow. There's various things that are required to make that to make that work. But a start is figuring out what those button presses are. So when it's time to go back and inject that message into the CANBUS, you know what message that screen or that ECM is going to be looking for to make it do the thing, right? As far as the fuel level goes, the most you're probably going to get, at least from my knowledge right now, is simply a fuel light, even with the Scout on the rod command screen, because the fuel pump does not have a float on it. The Chief does, and I think the 25 Scouts do as well. Yeah, they have a float because they have a fuel gauge. But the pre-Scout, it uses, I believe, a resistor-based fuel pump. So it gets to a certain point and it detects the resistance has changed and it turns the fuel light on. And I think it even turns on a little bit brighter when it gets a little bit lower as well. Whereas the Chief and other Thunderstrokes or other Indians, they pretty much like know at all times what the level is. So there's a lot to learn with this, man. But this is, again, all of this is required to try and get that screen working on a Scout. The good news is the pinouts, the can high and the can low, the power, the ground, all of that is the same between the rod command and the Scout. I think the oil level, not the oil level, sorry, the oil pressure indicator is different between Scout and Chief, and they actually pin out directly to the screen, but you can swap that. But anyway, this is the beginning stages again. I'm going to get back to this, and again, I'm working at it. It's a huge work in progress. It is a huge task to try and reverse engineer this stuff, and I'm going to see if I can get it to work. But let me know what y'all think down below about that. I'm going to get back to work. I hope you learned something. Thanks for watching. Here's another video for you to watch on this series. I'll catch you in the next one. Peace.